Okay, let's go back in time. Way back. We're talking 60 million years to meet a creature that's just, well, impossible. A creature so enormous, it basically forces us to rethink the very limits of life on Earth. This is the story of Titanoboa, the snake that, by all modern rules, simply shouldn't exist.
You know, the crazy thing is, our story doesn't start in the ancient past. It starts pretty recently, actually, in 2009. Picture this. You're deep in a sweltering, massive coal mine in Colombia, the Cerrejón mine. A team of paleontologists is digging around in the remains of an ancient rainforest when they find something, and what they pulled from the earth stopped them cold.
And this is where it all begins, a giant in the coal. This single discovery kicked off one of the most fascinating paleontological puzzles you can imagine, and it all started with one single, impossibly huge bone.
So what they actually found was a vertebra, a piece of a backbone. But this thing, it was thicker than a grown man's wrist. Now, finding massive reptile bones from this time period, the Paleocene, isn't totally unheard of. So the logical first guess, it's got to be a crocodile, right? Crocs were the known giants of those ancient swamps.
But there was a huge problem. The shape was all wrong. The curves, the structure, it didn't match any crocodile vertebrae they had ever seen. And then came that shocking, jaw-dropping moment of realization. These weren't crocodile bones. They belonged to a snake, an unbelievably massive snake. So once you get over the initial shock that you found a snake bone the size of your forearm, the next question is pretty obvious, isn't it? Just how big are we talking? So the team got to work on the incredible task of measuring this absolute monster.
The calculations that came back were so staggering, they had to run them again and again. They probably thought their math was broken. The most conservative estimates put the snake at 42 feet long, with some models suggesting it could have even topped 50 feet. That is longer than a school bus. And its weight was just as mind-boggling. We're talking around 2,500 pounds, so well over a ton. This wasn't just some big snake. It was one of the largest predators on the entire planet after the dinosaurs vanished. To really put that into perspective, let's look at a comparison. The largest snake alive today is the green anaconda, a true giant in its own right. Well, next to Titanoboa, it's completely dwarfed. Titanoboa was nearly twice as long and maybe 4 or 5 times heavier. And the human figure there? Yeah, we're barely a snack. So you might be wondering, how in the world can they know all this from just a few bones? Well, it's actually a brilliant bit of science. See, modern snakes have these predictable scaling laws. There's a direct mathematical relationship between the size of their vertebrae and their total body length. So scientists can measure Titanoboa's massive vertebrae, compare them to modern boas, and reliably figure out its full, terrifying size. But this all leads to a much deeper question. It's not just how big it was, but why? Why could a snake get this enormous 60 million years ago, but not today? Well, the answer isn't in the snake itself. It's in the world it inhabited. To get this, we need to talk about one key concept, ectothermy. You've probably heard it called cold-blooded. Snakes are ectotherms. They don't generate their own body heat like we do. They rely completely on the temperature of their surroundings to function. So here's the crucial link. The warmer the environment, the faster a snake's metabolism runs. And a faster metabolism means more efficient digestion, faster growth, which directly allows for a much, much larger body. Titanoboa wasn't just a giant snake, it was like a biological thermometer from the ancient past. And its world was a total hothouse. Average temperatures where it lived were likely over 32 degrees Celsius, or 90 Fahrenheit, year-round. There were no ice caps, no real seasons, just relentless steaming heat. And get this, today's tropical rainforests are actually too cool to support an ectotherm of this size. So let's try to picture it. What was it actually like for this creature to live and hunt in its superheated, swampy world?
First off, forget everything you've seen in monster movies. Titanoboa was not some lightning-fast serpent chasing things on the forest floor. No way. At 2,500 pounds, gravity was its enemy. On land, its own weight would have been crushing its internal organs, making any movement exhausting and inefficient.
The reality is far more interesting. Titanoboa was an aquatic ambush predator. It lived in the murky, slow-moving water of the swamp, which gave it the buoyancy it needed to support that incredible bulk. It behaved less like a modern snake and a lot more like a crocodile, using the water as camouflage, waiting silently, maybe for days, almost invisible, until the moment it struck. And what was it waiting for? Based on the other fossils found at the site, its diet probably included giant turtles, early species of crocodiles, large fish, and really any early mammals unlucky enough to get too close to the water's edge. It was the undisputed apex predator of its entire ecosystem. So, if Titanoboa was so perfectly adapted to its world, why is it gone? The answer is both really simple and a powerful lesson about our planet. To put it simply, the very climate that created Titanoboa was also the key to its destruction. When the world changed, this giant specialized predator just couldn't change with it. You see, after that peak heat of the Paleocene, Earth began a long, slow cooling trend. And as global temperatures dropped over millions and millions of years, the environmental conditions that allowed Titanoboa to exist in the first place just vanished. This was a slow-motion extinction. As the planet cooled by just a few degrees, Titanoboa's metabolism slowed way down. It couldn't hunt effectively or digest its food fast enough to sustain that massive body. At the same time, its prey, the giant turtles and crocodiles, were also dying out for the same reason. The entire ecosystem that supported it just collapsed. And that brings us to the ultimate takeaway from this whole story. Titanoboa's existence proves that climate isn't just some backdrop for life. It actively sets the rules. It dictates the absolute maximum and minimum size that a creature can possibly achieve. Titanoboa was a creature born of a uniquely hot world, and it died when that world cooled. It's a powerful reminder of how finely tuned life really is to its environment, which leaves us with a final question to think about. Climate defined the limits of life for Titanoboa. So, what limits is our climate defining